Hey everybody, Mag here. It's Thursday, April 16th, and nasty day outside today. So if we get to Saturday on, spring's gonna be here for good, hopefully this year. So tonight, I'm gonna show you horizontal asymptotes, and there's different scenarios you gotta be aware of. So last night's lesson, I talked about vertical asymptotes on rational functions, and now I'm gonna show you horizontal asymptotes. If your rational function has a number on top and a variable on the bottom, as soon as you see that situation, a number on top and a variable on the bottom, automatically the horizontal asymptote is going to be the x-axis, y equals 0. So on this function right here, the horizontal asymptote is the x-axis, which is the equation y equals 0. In other words, we're going to draw a dashed line right on top of the x-axis, and if we were to graph this rational function out, it would get really close to the x-axis, but it would not cross over the x-axis because asymptotes are like boundary lines that typically graphs do not cross over. So, and also if you have a function like this, if you have variables on the top and the bottom, but the highest exponent on top is less than the highest exponent on the bottom, is smaller, then same situation, the horizontal asymptote is also going to be the x-axis, y equals 0. So in both of these situations, there's going to be a horizontal asymptote at the x-axis. Alright, so that's that scenario. Now I'm going to show you another situation that you have to watch out for that's different. So say you have a rational function and the highest exponent on the top in the numerator is the same as the highest exponent on the bottom, down in the denominator. If you have that scenario, then you're going to get your horizontal asymptote by the coefficients in front of those variables. So the horizontal asymptote in this situation would be y equals 15 over -5, which is y equals -3. So if we were to graph out this rational function, we would put a horizontal asymptote at y equals -3. And once again, if we were to graph that out, it'd get really close to that horizontal asymptote, but it would not cross over it. Let me give you one more scenario like that. Say your function is once again, if you have a rational function and the highest exponent on top is the same as the highest exponent on the bottom, like highest exponent here's a 1, highest exponent here's a 1, it's the same. Once again, the horizontal asymptote is going to be obtained by the numbers in front of those variables. So the horizontal asymptote here is going to be y equals 6/12, which is y equals 1/2, because 6/12 is a half. So there's going to be a horizontal, if this is 1, there's going to be a horizontal asymptote at y equals 1/2 on this guy, okay? And then the only other scenario that you got to watch out for that's out there that I haven't discussed yet is, hey Mag, what happens if the highest exponent on top in the numerator is bigger than the highest exponent down in the denominator? What happens then? Good question, glad you asked. So, if you have 5x cubed over, say, x plus 4, where the highest exponent on top is bigger than the highest exponent on the bottom one, highest exponent up there is 3, highest exponent down there is a 1. If that's your rational function, there is no horizontal asymptote. You do not have one. There is no horizontal asymptote. You don't have one in that situation. All right, so now that I've gone over that, let me show you what you're going to have to do pretty much on the, what you're responsible to know. You got to know vertical asymptotes and horizontal asymptotes. There's also oblique asymptotes, but due to the situation, I'm not going to talk about oblique asymptotes. So, oblique asymptotes, by the way, are like diagonal ones. So, I'm just going to make you responsible for vertical and horizontal asymptotes. So, say we have g of x equals 7x over x plus 2. All right. To find the vertical asymptote, you're going to set your denominator equal to 0 and solve for x. Change sides, change signs. There's going to be a vertical asymptote at x equals -2. Horizontal asymptote in this situation. I'm going to change this instead of 7x. I'm going to change it to 4x. So we have 4x over x plus 2. Even though I changed that numerator, it's not going to do anything to my vertical asymptote because I didn't change anything down in the denominator. Notice highest exponent on top is the same as the highest exponent on the bottom. Well, what happens for a horizontal asymptote in that situation? It's going to be the coefficients, the numbers in front of that. So it's going to be y equals 4 over 1. So y equals 4 is where there's a horizontal asymptote. So to graph that, which you're going to have your calculator to help you, but y equals 4, 1, 2, 3, 4. There's a horizontal asymptote there. There's a vertical asymptote at x equals -2. X equals -2. There's a vertical asymptote. Horizontal asymptote at y equals 4. And then I'm going to grab the calculator, type this guy in. You can grab your calculator, type it in, y equals, I'm going to put 4x inside of parentheses, divide it by the quantity x plus 2. So the x plus 2 I'm also going to put inside of parentheses. Hit graph, and that guy is looking something like this. Alright. Now, these calculators that you and I have, the calculator tries to draw the vertical asymptote, so you'll see the calculator try to draw it, but the calculator doesn't draw the horizontal asymptote. But if you and I draw it, you can tell that it, there's one at y equals 4. So this graph is going to get really, really close to that horizontal asymptote, but it's not going to cross over. Over here, it's going to get really, really close to the horizontal asymptote, y equals 4. It's not going to cross over it, though. Same way with the vertical asymptote. It's going to get really close to the vertical asymptote, but those the graph of this are not going to cross over these asymptotes. So that's the graph of this function. And then the last question that you would have to know on this is, what's the domain of it? Well, the domain is what's going on with a graph horizontally. Well, this guy's going left forever. This guy is going right forever. However, it is undefined at x equals -2. So the domain, you could write all real numbers except -2. Or if you put that answer, that little squiggly means except -2. Or if you put that domain answer in interval notation, it would look something like this. It'd be negative infinity to negative 2, parentheses because it goes right up to negative 2 but does not include negative 2. The union symbol, which takes care of the word or from negative 2 to infinity. I wish I had a bigger board, but this is what I got to deal with. So anyways, so that's the domain. We've graphed it, we've stated the asymptotes, and that's what I got for you tonight.